This is the third video in a series of videos on Java map interface, and we're going to be talking about this in the context of the collections framework. And specifically, I'm going to do an example of using the HashMap to solve a real problem. Well, maybe not a real problem, it's kind of contrived, but it'll be a problem. So I have some text. I got an article off of Bloomberg about infrastructure or something, and what we're going to do is grab this text, and we are going to figure out how many times each word is repeated in the article, and what the most repeated word and what the least used word is. So I'm going to create a new class. I'm going to call it count word instances. So it'll be a public static void main. And the first thing I need to do is grab this file. I have a text file here called article, and I want to read it into my my program here. So I'm going to say path, and we're going to say paths.get, and I'm going to use my system property get property user.dir, and then inside of user.dir I'm going to resolve a file called article.txt, and that should resolve to that article in my current working directory. Next, I'm going to try to actually create a buffered reader. That'll be my reader, and I'll say new buffered reader, and inside of that reader I'm going to create a new file reader. And then we're going to pass the file in here, and you guys probably know what I'm going to do here. I'm going to actually pass in path.toFile. I think I can get that all on one line. I didn't want to let this go off the end of the line here. So, and it's yelling at me because that throws an exception. I don't really care about catching that exception, so we're just going to say throws exception, and let that be that. So the next thing I'm going to do, because I'm going to try to record how many times I see each word, I'm going to create a map, and it's going to be a key value store where the key is string and the value is integer. And notice I didn't use lowercase int like this. That is because I had to use the object wrapper integer, and the reason is map, it can only take objects. You cannot put base data types in there. So we're going to call this frequency, and I'll say new HashMap. Okay, and let's get rid of that. So what I'm going to be doing is using the string as the word and the integer as a counter for the frequency. And so the way that's going to work, if we find a word called an, then we'll put a 1 in there. We'll say put an, comma 1, and that'll be my string and my value. And then if we find an again, we will we'll do the same thing, except we'll increment it, and I'll show you how we're going to do that. And the trick we need to think about up front is, do we want to make every word lowercase or something so that we can do this without thinking about cases? Because obviously if you start a word, or if you start a sentence with a word like specifically, it's going to be capitalized, and if you compare those two strings together, unless you make them all lowercase or all uppercase, they're not going to equal. So I think we're also going to do some we're going to try and be clever about this and make everything lowercase maybe in our comparison. So what I need to do now is start reading lines in. So I'm going to say string line equals reader.readline, and that'll read my next line in. And I'm going to make a while loop, and the while loop is going to say while line does not equal null. So the way readline works is that as long as I have a non-null character, I have a I'll have a line here, and as soon as I read a null, that means I'm done reading my file. So here at the beginning, I'll say processing line, print out the line just for fun, and then I'll say line equals reader.readline. So we kind of read in the next line. Now, just before we do anything else, I'm going to run this class just to make sure this is working as expected. Right. So we processed all the lines, right? Now, now let's go ahead and start processing these lines and splitting them and doing everything we need to do. So here's the trick. What we're going to do is say string array of words, and we're going to do that by saying line.split on space character. So if we have a space character, we're going to assume that's going to be a separation between words, and we're going to split on that. Okay, and the next thing I'm going to do, I'm going to say if line.trim does not equal, whoops. So this is just a safety mechanism because I noticed there are some empty lines here, and that's just a new line character. So there's going to be nothing in there but a new line character. Sorry. And what we're going to do is make sure that we don't try to do any splitting on empty lines. So if the line after you trim it, and trim just means remove all the white space. So if I remove all the white space and it still equals an empty string, then I don't want to do anything. So that's what that bang there is. So I'll have my list of words with my split of a space character, and let's just make sure that worked. I want to, we'll throw in a debugger statement here, I guess, breakpoint, and I'm going to hit debug, and I'll hit F6, which is the next. That's a problem. So if I evaluate this, I can add that to my watch. Up here in my watch, I will see that, right, so that looks like it's working correctly. I'm getting an array with a whole bunch of nice words in here, and looks pretty correct to me, except for maybe when I have commas. We'll have to think about how we're going to handle that later, but this looks good so far. So let me cancel this program. The next thing we're going to do is say for each word, for string word in words, let's process the word. Okay, so I'm going to say string processed equals word dot let's do one more thing first. So I noticed there were some empty words possibly in there. What we want to do also is say if word equals null, or word dot trim dot equals empty space. What we'll do is we'll just say continue, because we don't want to process that if it's just something empty, right? If it's an empty word, we don't care about it. So that's just some sanity check here, some safety check. So that should take care of that. What we're going to do here is say word dot to lowercase. So we're always going to compare lowercase words. And here's our frequency map. That's what we're going to use for this map. So the next thing I'm going to do, I need to enter this into the map so I can start keeping track of stuff. And I'm going to say if frequency dot contains key, and we'll say processed. Then we'll say frequency dot put, and here's the trick: we need to put the processed word, right? But now the value, we're going to have an integer in there, so we're going to say actually let's save this for a second. Let's say if we don't find it, let's do this case first. This will make a little bit more sense. If we don't find it, we will say frequency dot put processed word. So this will be, for example, abundance, right? So processed will be the word, it'll be abundance, and then the value will be 1 because we saw it one time. Okay, now what happens if we did find it and we've already processed this word before, we're going to increment that count. So what we need to do is get frequency. We need to pull the value out and say +1. So there are two arguments to put. The first is the key, the second is the value. And in this case, we need to get the original value, increment it by 1, and then put it back in there. And what happens when you put on a key that already exists, it just replaces the value. That's all it does. Because the hash map, it will enforce uniqueness on the keys essentially as a part of being a hash table. So this should fairly well do what we want. I think at the end here, after this while loop, we're going to print out frequency just so we can see what we actually got. Okay, let's run through this and run this program. Okay, all right, so management, comma, well, with a quote, 1, projects 4, week, comma 1, year 3, don't 1. Okay, so we've got lots and lots of words in here, right? Lots and lots of words. What if we want to find maybe the most commonly used word? That'll be interesting. So the problem is we can't easily do that unless we happen to be sorting the values. And so a way we're going to be able to do that is we can get the values out. So on a map, you have methods to get the keys and the values. So you can say frequency.keyset, you can get the values, the keys, and you can say values and get the collection of integers. Now the only trick is that the collection of integers, if you grab that, then you don't know which key it's going to pertain to. So we have a problem now. So let's make this simple for ourselves, and let's just get the very highest frequency item. And the way we're going to do that is just iterate over the key set. So we'll say for string word and frequency dot key set, and that'll give us every single word that we can iterate over. And I'm going to say int most frequently used equals 0, and we'll say string the word. Okay, and what we're going to do here is loop over this key set, and we will say if frequency dot get key. So this is going to return a value because we're getting the key, which is a word, word, and it'll be an integer, and we'll say if that's larger than most frequently used, this is going to be kind of our number that we're going to use to keep track, then we'll say most frequently used is now equal to, well, let's do a quick optimization here, just so that we can not have to call this multiple times. Let's say the val equals frequency dot get key. All right. Whoops, word. So now we don't have to do this multiple times. So we'll say if the val is greater than the most frequently used counter here, which this is just something we're going to use to keep track of the most frequently used while we go through this loop. We'll say the val is equal to that since it was larger, and then we'll say the word that corresponds to that is word. And by the end of this loop, we will know what the most frequently used one. So we'll say syso, and we'll do, let's actually do printf. Is that a thing? Yes. So we'll say the most frequently used word is S, and it was D times, and the arguments will be the word and most frequently used. So by the end of this, we'll have our answer essentially. And I'm just going to comment this out so we don't get all this spam in our console. And let's run it. Let's surround this with quotes. It's one more thing we'll do, just so it's easier to read. So the most frequently used word is the, and it was used 50 times. So that's kind of an obvious one, right? That kind of makes sense. So anyway, at the end of this, we got a huge map, and we got the frequency usage of each word through this map. And if you wanted, you could go through and clean this up. You could do stuff like, replace everything. You could say processed equals process.replace everything with a comma with empty space, and then you get rid of all the commas because I saw commas everywhere in there. And you could keep doing stuff like that till you clean it up and got your application better and better. So you see all the commas are gone. Now I've got different words in here, so it's kind of interesting. And you've got other odd things in here. A negative sign, maybe that's not even a word, right? So but anyway, once you've built your map, you can go through, do all kinds of manipulations. You can loop through the key set and find, you can do comparisons. But this is just a way to solve building a frequency map of the number of times each word is used in a big piece of text. All right, thanks for watching.